Next problem is a course grading using array operation. Okay. Here's a grade. Okay. So this one is a perm is to generate the one number from 1 to 61. No, this one is to pick the 7 number. Okay, so for instance, ram perm. Okay, all the number is between the 1 to 61. Okay, without the overlap. Okay. So rand I is the 61 7 sorry 7 1 sorry 1 7. So there's a chances of the numbers are overlap. Yeah, see this chances the numbers are overlap. Ramp perm to avoid this overlap the number. Okay. Okay, so here the score is the 5 by 7 matrix. 5 is a number of exams, 7 is a number of students. Okay. Here's the ID is the location of the column. Okay. First column is the here this is the 1 by 7 7 vector, right? First one is the score for student 1 at the exam 1. Second value is the student 2 score at exam 1. That's why in the score matrix, each columns are students' score. Okay, for this 5 different exam. Okay, you should not use the loop statement to solve the following problem. Okay. I mean, this one is I'm just saying that you can solve this problem without using the loop statement, because I'm trying to encourage you to use this operator rather than the loop statement. This doesn't mean that solution using the loop statement is inferior than the solution using the operator. Okay. You can use the loop statement, but this tutorial encourages students to practice using the operator. Okay. The tutorial course grading. Okay. Question A. And then copy this code. A is the create the variable named the num. A contain the number of students get score of more than 60 in first exam. Simply, where's the fourth exam? Number of students who get the score more than 60 in the first exam is the fourth rule, right? Score the fourth rule. Okay. Okay. I just put this one in the one line, but you can maybe score exam 4. You can write a script like this. Okay. And B is the weight. Create the student score. B is contain the student score. This score is the closest to and larger than the average score or fourth exam. Okay. So let me first compute the average score. Average exam 4 is the mean score 4, right? Or because we already assigned this first exam score in the score exam 4, right? Okay. How to find out the score is the closest and largest than average score? Okay. Okay. Let's see this example. $91, $41, $92, $71, $47, $100. Okay. Average is 68.86. Okay. The value that we are looking for is the 71. Okay. First, the condition is the larger than average, right? Okay. Closest to the average. Okay. Okay. So let me sorting this number vector 1 first. So sort vector 1 is the 100. Okay. Let's do this ascending order. 41, 43, 44, 71, 91, 92, 100. Okay. Okay. Average is around. Okay. Try out developing the logic to pick this number. Okay. What is the characteristic of this number? That is 71 is the smallest number among the number which are larger than the average. Okay. These are it's the same thing, but this is the way of developing the program. Okay. Does it make sense? Okay. Let's move to this window here. Okay. Okay. The first we are identifying the score is larger than average score, right? This one is a logical vector, right? Score larger, score exam 4, more average. Okay. Okay, more average. Okay. See this? This one is a logical indexing, right? This one logical indexing, and then read only the value is more than. Only the value is this condition is true. Okay, right? Then we are going to only. So this code is let us read only the. Sorry, this value, right? Okay. The value is not stored. We don't have to store this number, right? This script is only to pick this set of the number. What is the condition? That script is to conduct this part, right? number which is larger than average. So the answer is student score B is just the minimum. Okay? Does it make sense? Okay. Okay, what about the C? C is the weighted score. Okay. So I repeat this problem several times. So we need to use matrix multiplication, right? So we first define the weight factor, that is a 10%, 15%, 20%, 25%, and 30%. Okay. So let's do it in the column vector. Okay. And then weighted score is score. Okay. Score matrix is the 5 by 7, right? Weight factor is the 5 by 1, right? So this one is 5 by 7, 5 by 1. Okay? You can do the matrix multiplication in this way, right? Score, the point is weight. Okay, we cannot do, right? Inner dimension is not matched. So one way is the weight factor transpose multiply the score, that give you, this one is 1 by 5 because it's transpose. This one give you 1 by 7 row vector, or we can transpose score factor weight factor, that is so 5 by 1, this becomes 7 by 5. Okay, it does 7 by. Okay, all these two operation is to find out the weighted score. Okay. Okay. I mean, the similar problem is to this one is the homework 4 and the equipment purchasing. So please review this video if it is available. Okay. So score weighted score C is D, but in this case the question is asking the 7 by 1. So this one score transpose multiply this case. So this one is better. We can compute this weight score vector and then transpose. That's the resulting, the vector are same. But let me take this the second one. Weight vector. Okay, makes sense. What about the D? D is modifying the score. Score is less than or equal to 50 is considered as a 0. The more than equal to is a 90. Okay. So in this case, I need to update the score, right? Weight is the same. I only need to update the score. So okay, the score is assigned. So initialize with the score. Score new. Let's directed put this expression inside of the inside of this parenthesis. Score new less than equal to 50, that is assigned a 0. Okay? Score new is more than equal to 90, assigned 100. Okay? This one is exactly same with this one. Okay? Only difference is I put this expression inside of the here. Okay? There's no difference. Okay? And then weighted modified score D become a score new transpose weight vector. Okay? Make sense? Okay. Run it. Score new. Run it. No error. Okay? Then copy this code. Then paste here. Okay. Why it's not working? So, okay, good. Run script. No error. Submit. Okay, good. Okay, the final question is the parking data. Okay. There's no example of the parking data in the homework 5, but you will see there's a couple of the other questions in the future. Okay. This parking data is a very good question is to study the 3D matrix as well as a kind of the logical operation. Okay. And also this one is a kind of the realistic problem. Okay. So let me first read this question in detail. Okay. So you want to determine how often cars are moving from the parking spot at the mall. Parking data is 20 by 20 by 11. So in this case, 11 is the number of the time. So 8 to 6 p.m., right? That is 11 time window. Then the layer, there's this matrix, the parking data matrix 11 depths, right? So 20 by 20 2D matrix is stacking 11 depths, right? So each matrix represents the parking status of the specific time. First layer for parking status for 8 a.m. Second layer is the parking status of the 9 a.m. Okay? The mall open at 9 a.m. and close at the 5 p.m. Okay? So 8 a.m. and then 6 p.m. the parking lot should be empty. Okay? That's why if you see this given code, I first generate the empty lot. Okay? And then parking data is to generate the cat is to concatenate the matrix in the depth direction. First layer is empty lot, and then I generate the 9 different, this parking lot data, 20 by 20 parking lot data. And then I appending the empty lot again. This one represents the parking status at 6 p.m. Okay? Make sense? Okay. So here's the example. So let's assume that you have a 5 by 5 by 6. This means 4 working hour, and then beginning and end is adding 2, right? Before opening the mall, so after closing the mall. That's why this is a matrix of 5 by 5 by 6, right? And then these are matrix in the 5 by 5 matrix and each time window. Okay? Basically, this is a parking lot data stacking all this 6 matrix in the depth direction. Okay? And then, so numbers of the field, which is the scalar value, represent the total numbers of the spot that are filled with a car. Okay? Each hour, so here, each hours, there are 400 spots, right? So the total number of spots available for 9 working hours is 3,600 spots, right? But among the 3,600 spots, how many spots are filled with a car? Okay, for instance, here 8 a.m. so 1 p.m. is empty, right? Should be empty. Okay, so here's 9 a.m. There's a 5 filled, 6 fills, a 4 filled, and a 3 filled. Okay, basically number of filled is the adding the all this number, okay, or this one number. Okay, so we can first solve this question. Tutorial 6 parking. What's the name of the parking data? Okay. So A is the 4. Okay. Let's first define the num hour. Num hour is the 11, right? This one is 11 depths. 4 II is equal to 1 to num hour. And then we read the parking data hour is the parking data. Okay. Do you understand what it is? This one is now is a 20 by 20 matrix, right? Okay. And then, so basically here is a non-fill. So set to 0. And then we are adding the parking data. How data hour all. Okay. That's it. Take a look at this example. First read the first layer and then adding all the one, right? All the one. And then adding this sum of all one to the non-fill. This is a 0, but 9 a.m. is there's a 5 1, right? So this should be the 5 in this example. So 5 is adding to the non-fill and 6 adding to the non-fill. So basically this operation is to conduct computing the number of the fill, right? Okay. Does it make sense? Okay. So, I mean, this is optional. Another way is you can solve this like this. This is optional, okay? 3D matrix is also flattened as a vector, okay? So we flatten this parking data as a vector, and then summation, that is the same with this operation, okay? Okay, good. Max occupancy and the mean occupancy. So find out the times of the day, the most spot occupied. Mean occupied, find the time of the day with the fewest spot occupied when the mall is open. So because the 8 a.m. 6 p.m. is numbers of the fields is a zero, right? There's no car, so mean occupancy should be the zero, right? If we include 8 a.m. and 6 p.m., right? So I take out the 8 a.m. 6 p.m. to compute the mean occupancy. Okay. This one is to find out the times of the day with the most spot occupied. Okay, if you take a look at this one, so 9 a.m. is a 5 filled, 10 a.m. 6 filled, 11 and 4 filled, 12 p.m. is a 3 filled. So the most busiest times of the day is a 10 a.m. So that's why the max occurs to become a 3. Why? 8 a.m. is a first layer, 9 a.m. is a second layer, 10 a.m. is the third layer, right? And then what is the minimum occupancy? That is the 12 p.m. That's why 5 is assigned to the mean occupancy, 1. Make sense? Okay. The how to find out this times of the day. Basically, we first find out the numbers of this fielded, the number of the field and each time, right? So we take this structure. Okay? So we first define the per non-fill hour. That is the, what is the vector? 1 by norm hour. Okay. Then we change this line with the non-fill hour. Okay. So now we obtain the numbers of the fields of each hour. Those informations are stored in the non-fill hour, right? And then, so we are going to find out the index, right? And it's not the value. That's why we place this occupancy here, and then max non-fill hour. Okay. Similarly, mean is the like this. Okay, do you think this is correct? No, right? Because a non-fill, maximum is fine, but non-fills include this 9 a.m., 8 a.m., and then 6 p.m. data, right? Because they're 0, right? So we need to specify the dimension to the second to the n minus 1. That is the times of the day when the mall is open. Okay? And do you get this point? Okay. Do you think that this solution is correct? No, right? Why? Think about, let's say 9 a.m. is the minimum occupancy. Okay? What value is assigned to the mean occupancy here? I mean, the correct solution is a 2, right? 9 a.m. is a 2. It's the second layer, right? But here, if the 9 a.m. is the most busiest time, mean occupancy here is the 1. Why? This is the vector. This vector is the starting from the second element to the n minus 1, right? So busiest time, so 9 a.m. data is placed in the first element. Okay? That's why you need to add the 1. Like this. Okay? Does it make sense? You need to correct this value. So C is the numbers of the part left. Okay, so let me explain what this means. Okay. So let's explain by this example. So there's no car at 8 a.m., right? No car. Okay. 9 a.m. So 5 enter, right? New 5 car enter. So no left, right? So let's take a look at the 10 a.m. This is spot and this spots remain unchanged, right? This means new car, 4 new car is entered, right? And then 3 cars, this one, were left, right? Okay, this example is wrong. I think that this should be the 0. Okay, so I'll fix this one later. Okay, you'll see the correct example. So here 5, 1 2 3 4 5, so 5 enter, right? If this one is a 0, and then car with the marked orange colors were left, right? That's why you will see that 3 left, and then 4 orange. Okay, this one 3 left, and then 4 enter. Makes sense? And then 2 are stay there. Okay. What about the 11 a.m.? 11 a.m. there are 4 car, and this one is still there. And then how many cars are left? 3 left. What is 3 left? That is this one, right? Then this one. Oh, this one, right? Okay. 3 left. And then how many enter? This guy is a new enter. Okay. Does it make sense? Okay. How do we identify this number? That is, so you can just see the difference, right? How? If you subtract all the value from this one, if that is a 0, there's no change, right? Like this value or this value. Oh, no, not this one. So 0 value, like this one, okay? But if you do this one is a plus 1, that is the enter. Okay, but if the minus 1, that is left. Make sense? Okay, so the numbers of the cars are left, the numbers of the car entered using this information. Okay. Okay. So here, this one. So let's first all solve the C and D at the same time. With numbers of the part, enter is set to 0. Numbers of the left to 0. Then we can set the loop statement 1, 2. We are going to see the difference, right? So we are setting this loop range is 1 to 10 num hour minus 1, not the 11. It's the 10, right? Because there's only the 10 difference between this layer, right? Okay. Oh, by the way, here is the num-part left is a row vector, not the 0. So 2, 11, 2, 11. Okay. By the way, it's the number of part left and number of car enter at the AAM. That's a 0, right? So none of the cars enters, and none of the cars is the left, right? At AAM. So that's why that is a 0. So we are going to compute this number of enter, number of number of enter, and number of left from the 9 a.m. Right? So how the first part diff is the part data plus one layer ahead, okay, minus part data current layer, okay. Okay, then your num part left is the II plus 1 become a sum part differ equal to here. Okay. So equal to 1 is enter, equal to minus 1 is a left. So equal to 1 is the so this is minus 1 is the left, right? Left and enter. That is the. So let's see this example. But this one, you can just compare the 9 a.m. and 10 a.m. How do I find the numbers of the entered at 10 a.m.? That is, so we can subtract this number to the 9 a.m. data, right? If there is a 1, that is the numbers of car entered, right? If it's a minus, that spot is a car is already left. That's why. So numbers of the minus 1 is the numbers of the car left, right? That's it. So here, part difference is the part data is II plus 1, and minus is the current layer. So basically, the first value of the num car left and num enter is 0, right? Because again, AAM, there's no car enter nor car left, right? So this one is we're starting to assign the new numbers from the II plus 1. Okay, think about this one is 9 a.m. data. If an II is equal to 1, 9 a.m. data, this one is 8 a.m. data. We subtract this value, minus 1 left, plus 1 is enter. Okay, makes sense? Okay. E is the most filled spot, which is the scalar value. What is the longest time which spot? This one is basically you're summing up this for instance here, this should be the 3, right? This is a spot, red spot is a 3, this spot is a 1, and this spot is a 2, right? So you're just adding all the value in the depth direction. Okay, so basically you're designing the for loop. So 1, 2, num hour some park stay 0, 20 by 20. Okay. Then you're adding plus park data like this. Okay. Then you're most fill the spot is going to max some park like this. Okay. Do you get this point? Okay. Think about it's a 20 by 20, matrix in the 11 depths. Okay. So each spot is represented as a parking lot spot. Okay. If you have this parking data, how to compute the numbers of the hours filled it, the numbers of the hours filled it with the car each spot. That is you can just the summation of the 11 layer data, right? Basically, you are adding this layer in the depth direction. Does it make sense? Okay. Good. So we can copy this code. Oh, we first just run it. Okay, where's the park? Not parking data, right? Parking data. Run it, no error. Copy this code. Paste here. Run script. Oh, I didn't copy the num hour. Here. Num hours. Run script. No error. Submit. Okay, good. Okay. This parking data problem is tricky. Okay. But I mean the problem itself is very obvious, right? Each layer is represent as the parking spot is filled or not, right? Then how to process those data to find out the this variable. So number of the cars, the left and enter, and the maximum occupancy or something. Okay. Okay, good. Okay, so please review this problem carefully and then see you next time. Bye.